Shall we start?
Udah. Kamu moderator kan?
Moderator.
Nanti kalau kamu dengan
Oke. Itu suruh baca dulu. Udah di briefing belum? Teksnya mana? Yang itu buat baca itunya? Lah, ini belum ada. Should we start? Should we start?
If you recorded your class,
Yeah.
it's okay.
Okay.
Let's wait. Kayaknya ya, buka tolong dong, ambilin. Oh. Ya kan? Boleh. Ya. Ya udah deh.
Okay, good afternoon everyone. Welcome to Pycon APAC 2024 for 5th session hosted here at Nahdlatul Ulama University, Yogyakarta. My name is Ivan Hakim and I will be your moderator for this session. It is my pleasure to introduce our speaker for today's event, Mr. Tarun Jain. Mr. Tarun Jain is a data scientist at AI Planet, a Belgium-based AI startup. Today, we are fortunate to have them here at Pycon APAC, where they will be sharing insights on building agentic workflows for planning and reasoning with LLMs. Please join me in welcoming Mr. Tarun Jain.
Cool, yeah. Thank you for the introduction. So I'll probably start off. So I just wanted to know how many of you are aware of retrieval augmented generation from yesterday's talk? Okay, no worries. So yeah, in today's talk, probably I'll be telling you how, what are the different techniques you can use so that LLM can reason and plan itself. And there are few tips that you can use as well. And at the end of the session, probably I'll show you few prompt engineering and also a demo on how you can actually build your first agent with just few lines of code. So in order to start with, I'll just introduce myself. I work as a data scientist at a startup called AI Planet. And I'm also a Google developer expert in AI/ML. I give few talks regarding RAG agents in Gemini and Gemma as well. And I was also part of Google Summer of Code 2024 at an organization called Redden Labs. I was also part of Google Summer of Code 2023 at an organization called CA Microscope. So yeah, let's begin with an motivation. So in the February 2024, there was a tweet that Andrew Wenzi made, the founder of Coursera and DeepLearning.ai. Probably known as the godfather of AI. And the tweet was, AI agentic workflows will drive massive AI progress this year. Ever since this tweet came out, there are so many open source frameworks which came out. It can be Crew AI, it can be AutoGPT, and there was one more famous agentic workflow, Baby AGI. So this kind of tools, right? This is where agentic workflows actually came into the existence. And ever since then, there are so many research that went through, and the prompting was improved, the way we write prompts. Then the LLM also improved significantly from 2024 to the existing time as of now. So let's take one step at a time and understand how exactly you build agent and why do we need an agentic workflows. So one of the best example of agentic workflow was Devin AI, which is the first AI software engineer. So the goal of agentic workflow is to imitate humans. So how do we humans execute a task? Now let's consider you have a chat dev, right? And if you look at this image, there are different teams. You have a documenting team, you have a testing team, you have a coding team, you have a designing team. So whenever you give a task, you're delegating the task to a different teams. So each team is expert in its own domain. So if you have a task which has designing that needs to be made, then you have a designing team who is expert in the task. And once the designing is done, if you want to code that particular part, then you have a coding team who is expert in converting your design into development to the prototype. And once you're getting into the production stage, you have a testing team who will test your application. And once the testing is done, you'll probably release the documentation so that the end users can use. So this is how we humans execute a task. We have the task, we decompose it, and we execute it till the end of the goal. Similarly, we have agents, right? Now let's understand how agent actually think and how it exactly execute a task. So I have a problem statement. I want to know whether I need to take the umbrella. And so the problem statement is I want to take an umbrella for tomorrow. So I just want to make decision yes or no. So in order to make this decision, first I will look into the environment and I will make a perception. So one of the perception that I can make is I need to look at weather API. So now once I have the weather, I look into what will be the tomorrow's weather. And based on the tool information, I will take an action. And that action is where I need to have a decision making. Hey, tomorrow it's gonna rain and I need to take the umbrella. So I need to take the umbrella tomorrow. That's a decision that I'm making based on the action which I got. So the action step here is nothing but you're looking into Google, getting the weather report, and then you have your brain who is making the decision. Hey, it's the X temperature and you're supposed to take the umbrella. So based on your environment, you make the decision and you're giving the results out of it. So this is how agent actually thinks. And now if we look at components, how exactly you build agents. So let's look at one component at a time. At first, you have a tool. So what exactly this tools does is it takes the information. For example, if you want to build Perplexity AI kind of tool, right, where based on your query, you're doing the Google search, getting the result. So you need to have certain action from where you're getting the information. For our example, tools is the first step for the agent, which will make sure to get the context. And this context, it can be in any format. It can be calculator, it can be a normal search. One of the best example of agent is Copilot. So what happens in Copilot? You have a GitHub, which is your framework, or the entire code is on your GitHub. Now what you're supposed to do, you're supposed to get a LLM. Now whatever query I have from my code base, any code, it should be able to answer. So this is the task of Copilot. It can be code generation, it can be answering the user questions. So this code pilot or code interpreter is your tool from where you're getting the information. And you also have search. Search, it can be weather API search or anything from wherever you're getting the context that is considered as tool. And once you have the context, you're giving it to the action, which will make sure that when to use which tool. So action is probably that component which will make the decision on what tool I need to use based on the user task. Now, once the action is done, the next thing is you need to make the decision. And when the decision is coming into the picture, you need to plan. We humans plan, right? If I give you a task, you plan the task and then you decompose it and then execute it. So there are two steps here when it comes to planning. First step is whenever a task is given, you need to create a task creation. And once the task is created, which is decomposed, the next step is you need to execute it. So task creation and task execution. There are two prompts we are supposed to write, and I'll tell you how these prompts are usually written. And once the planning is done, you also need to have a component of memory. So this is one of the most important part because what are we humans? So if I make any mistake, the next time when I'm given a same task, I will know that, hey, last time I made this mistake, I don't want to repeat this, right? So how do we implement this memory? There are two ways. One is you have short-term memory and one more is long-term memory. And for long-term memory, you have a concept of RAG. So I'll just touch base on a very high level on how you can use RAG for your memory. So I'll give you an intuition. Suppose you have a large language model. If I ask large language model about my own data, it won't answer. Why? Because it is not trained on the information that I have. So now what you need to do is you need to create a knowledge base of your data, and then whenever a user query is given, you will extract the relevant information, then give it to a large language model. So how am I relating this with a memory? In memory, let's suppose you have an agent, you have 10 conversations that you have made, right? Now out of this 10 conversation, only 3 of them is relevant to the existing task, right? For example, suppose I want to write a coding in Python, right? From my previous experience, I have used multiple frameworks. Now, whenever a new task is given, I just have to go to those tasks where I've used Python. So this is where you're getting the relevant experience from the past and giving it to a large language model. So this relevant experience, if you want to extract from the memory, we use a concept of RAG, where you're using search. So yesterday I gave a very detailed workshop on how you can build a RAG. If in case you're interested in knowing how it is built and how you can actually build it using Llama Index, this is the link of my slides and also the code representation. If you want to look into it, probably this is the link. I'll just wait for a few seconds if anyone is interested. So the link name is Pycon APAC. So the implementation was done using Llama Index and Qdrun. Okay, now coming back to the components, as we already mentioned about tools, which is getting the context and giving it to the action so that it can make the decision. And then you have planning, which is the actual important part in the entire agent. And there is a very nice research paper which was written by Apple team recently. And they made a claim saying that LLMs can't reason and they can't plan. And there are so many observations that they have made, which they wrote in that paper. So you can check LLM reasoning, Apple. And one more alternative, what they said was LLM can't reason and they can't plan, but they can help you design and structure it. So this is what we will be looking in our talk as well. So this is the research that has been conducted in just one single area, which is your brain part. And the main focus for our talk will be these two things, the reasoning and the planning. And for the planning, again, if you see, there are few prompt techniques which is written. You have COT, which stands for chain of thoughts. Then you have zero-shot prompting. So there is too much of information here. So now let's break this down. We'll take one research at a time, and we'll start with the prerequisite so that too much of information won't be burdened to you. So the first thing is you need to know what are the basics of prompting. You have zero-shot prompting. So if you look at zero-shot prompting, I ask a very direct question. All of us are using LLMs, right? Is there anyone who is not using LLMs? Okay, everyone knows what ChatGPT is, what Gemini is, right? So we write a prompt. And how does our prompt look like? It looks very basic. You write a straightforward prompt and you get the result. But if you actually want to get better result from your large language model, you use this kind of prompting, which is few-shot prompting. You give the context to the LLM, and then you ask a query so that LLM knows the context aware and then give you the better response. So these are the two ways. And every one of us have already used this. And one of the best example of few-shot prompting is whenever you're writing code, right, you might end up into error. And that error, you might not know how to solve it. So you copy that error message, you give it to a large language model, then you ask, hey, can you fix this error? So this is what you call as few-shot prompting. All right, so now that you have the understanding of what zero-shot prompting and few-shot prompting is, let's start with chain of thoughts. So chain of thought, it's nothing but whatever task is given to you, you need to break that into step-by-step solution, right? And the prompt is very simple. I've added two examples, one from GPT and one more from Gemini. So if you look at the first line, I'll just read out the prompt. It's related to aptitude. I went to the market and brought 10 apples. I have 2 apples to the neighbor and 2 to the repairman. I then went and brought 5 more apples and ate one. How many apples did I remain with? So it's a very aptitude question. So what you need large language model to do is, it needs to think step by step rather than giving a direct result. What happens in zero-shot prompting is, whenever you ask this prompt, it will give you, there are 10 apples remaining. It will directly give you the answer. Same happens with few-shot. You give the prompt, you're getting the direct result. And when you're planning, right, you don't need the direct result. Rather, you need the step-by-step approach on how you need to tackle that solution. So this is where you will have the understanding of how the task is actually decomposed. So this is where if you look at the first line, just notice the first line. from ChatGPT, the first line says, let's break down the steps to find out how many apples you have. So let's break down the step. So this kind of keywords, right, breaking down into steps is what you use for chain of thought. And same for Gemini as well. Let's solve this step by step to find out how many apples you have. So internally, GPT and Gemini both are using chain of thought. And originally, this paper was written by Google research team, which is the brain team. All right. So now if you look at chain of thought, it's very good and you're getting the better result. But when it comes to making strategy, right, do you think getting the step-by-step solution is your direct answer? No, right? Each task that you have might have 100 subtasks. It's not the end of the task. So in order to get that subtask from a single task, you have chain of thought. So now, tree of thoughts. What happens in tree of thoughts is, it is similar to chain of thought, but the only thing is, each decomposed step will have further decomposition, which is if you have one task, that one task will have 5 subtasks. So this was the goal of tree of thoughts. And when are you supposed to use this? If you want to make any strategy, right? If it is related to marketing campaign strategy, tree of thoughts is one of the best prompt you can use. And how is this prompt written? You just have to tell, hey, you need to think step by step. And once you think step by step, each task that you are giving, it needs to have further decomposition to get the end goal of it. And this is, if you notice the difference, right? When I ask LLM to develop a marketing strategy, chain of thought, it is directly giving you a result. You need to identify so and so, then you need to research it. Whereas tree of thoughts will break each task into subtasks. So you just have to tell, once you have the task, further decompose it. So it's a very simple prompt, and there are so many examples out there which you can use. Okay, now there is one thing you need to notice. Above my slides, till now, I used a keyword, agent without feedback. So what we do in agent without feedback is, there are two things. One is task creation. The second is task execution. So far, we only looked into task creation. Once the user gives a prompt, you're creating a subtask. So in order to do this subtask, you have chain of thoughts and tree of thoughts. Now we will get into the execution part. We have the task, let's execute it. Whenever you want to execute any task, you need to have a feedback mechanism, right? Let's suppose if I build a coding app, there is a testing team who will give me feedback. Hey, this is not good. Can you improve it? So you need to have that feedback mechanism. This is where we have a research paper called React. So React, again, it's a prompting technique which has agent with feedback mechanism. So you can notice about agent with feedback. So let's break down how it is actually built. So now let's suppose you want to know which is the latest Apple model or latest Apple iPhone, which Apple has released. So what will you do? First, you will ask the LLM to think about it, right? Now, once you give this query, LLM will run thought process on what it needs to search. And once it runs the thought process, it has something called as action. So what action it is taking? It is taking search. That means whatever Apple iPhone you need to search, it will go to Google API, or it can go to DuckDuckGo. Any search web browser, it will get the information. Getting the information is the task of the action. Once it has the input, which is the action input, it will give to the observation. So observation is where you have the final result from the LLM. Now it doesn't end there. What will happen is, LLM will think again, is this the final answer, yes or no? If it is the final answer yes, then it will give you the result. If it is no, it will think again. And during the next process, what it will think is, it will take the observation. From the observation, it will notice what are the major keywords. From those keywords, it will again do the thinking process, which is the thought. And from there, it will use the action to get the search context. And from there, it will again use the observation. This will repeat until you have the better response, and it acts exactly as human or very close to it. So there is two feedback here. How do we actually stop, right? There might be high chances that you don't get the output, and it might run in an infinitive loop. So there are two ways. One, you can define an output key in your prompt. And second is, you can have maximum iteration. That thought, action, observation can only run for 10 times, can only run for 20 times. Once it reaches the maximum iteration, you need to tell LLM to force the output on whatever analysis it has done. You just have to force the result. And this is what many libraries are doing. One of the famous library is LangChain. They released LangGraph. And if you notice their code base, right, of React agent, they're using the concept of output key. All right, so this is how exactly the prompt is written. So if you notice the first line, you run in a loop of thought, action, observation. At the end of the loop, you output an answer. So this is the first line, and whenever you write React prompting, you just have to make sure that you give these three keywords, which is thought, action, and observation. And the next important thing is you need to add whatever tools you have, right? If you notice the diagram of what are the components, you have agent. For that agent, you are giving the list of tools. And then you have React agent who will take the action. So you need to pass all the tools that you have. It can be your search, it can be calculator, it can be your code related GitHub API, and it can also be documents. Suppose if you have a documents and if you want to get information from your documents, even that is a tool. From wherever you get the context, use that as a tool and pass it inside a prompt. And then LLM will decide, which is your React agent, when I need to use which action. That's where you have to give that particular information. Here, for an example, the action is Wikipedia. So whatever question user is asking, you only need to use Wikipedia to get the context. So this is one example. And now if you look at the response, I have who won T20 World Cup 2024. I am a cricket fan. Then you have a thought. So this is the user query. After user query, LLM will do the thought process, and then it will look what action it needs to take. So what is the action now? It is doing QA search. So this is one of the search technique which I built using Tably. So Tably is one of the advanced web browser that you can use to get actual response from the web browsers in a simple context. So it will run this action. So this action is what you are running it on Tably, and then you are getting the answer. So answer is nothing but your observation. So this is the prompt technique. And if you want to dive in detail on how exactly we build it using code, I also have a step-by-step solution on how you need to start with function calling, then how you need to proceed with the agentic workflow. So this is the link. You just have to search bit.ly React agent, and you have a 40 minutes video on how it is actually built. Okay, now the last prompt technique for today's session, and that is regarding LADS, which stands for Language Agent Research. This is the advancement to the React agent. So it's similar to what happens in chain of thoughts and tree of thoughts. So what was chain of thoughts? You have the task and you're decomposing to step by step. And tree of thought was the root of it. Each observation has a multiple step. Same goes for LADS. In backend, it has the React. So whatever observation you have, that's not the end of the observation. Rather, there might be multiple observation. So you're creating certain node. So this is inspired by a famous search, which is Monte Carlo search. It's a search technique which many people use for DSA, where you have graph-related search technique. And if you notice here, you have the thought observation. This is React. It has only one observation. What LADS is doing is it will give you multiple observation, and then it will think which is the better solution to give it to the next thought process. So it's just a tree structure that you're creating for React agent. And all this agent, right? Now you might be thinking, how will I implement this? It might be too much of lines of code. It will just take you 10 to 15 lines of code if you're using a framework called Llama Index. And let's look at the code implementation. All right, so the first step is you need to import your whatever libraries you have. We'll be using Llama Index. The LLM that we will use is Gemini LLM. And then you have function tool. Why do you need function tool? So that you can have the tool component to do the search. So for search, we will be using DuckDuckGo search. And then you have React agent. So we have all the three components that we need. One is the tool, one is the large language model, and one more is the React agent, which is the planning part. So the next step is you need to add your API key. So what is the API key? You just have to go to Google. You can get it from here. So you just have to open Google AI Studio. And once you click on Get API Key, you have to create a new API key. And you just have to copy this key and paste it in your notebook. All right, so once you have the LLM in place, the next step is you need to define the tool. And one thing is whenever you write code, just make sure you have a doc string. Docstring is very important when you're building agents. The reason is, I told you, right, you have 10 actions or 10 tools. Out of the 10 tools, the action will make sure that which tool I need to pick. How will action know which tool it needs to pick? That is using the docstrings. So whenever you're building an agentic workflow, either from scratch or anything, just make sure you give the docstring and proper information on what the tool is doing. For example, I'm using a DuckDuckGo search and I'm telling this search tool is to get the search results from the user query. So this line is very important, right? And the second thing is whatever you return, it should be a string. So what DuckDuckGo search does is it will return a JSON file. And in the JSON file, it has metadata, it has URL, it has at what time that article was released, and it has other information. So what I need is, I just need the context and the metadata. So I'm extracting the body out of it. So why am I running a loop? Whenever I use a DuckDuckGo search, I'm taking the top 4 results. The top 4 results, I'm concatenating it in a single context, and then I'm returning it. So this is a simple tool process. The only thing that you need to keep in mind is the docstring. And once you have your tool in place, the next thing is you just have to concatenate everything. One is you have a search tool, which is your DuckDuckGo, and the second component you have is LLM, and then verbose. So what verbose is, whenever you're running any code, right, there is a runtime. Whenever there is a runtime which is happening, if you want to see the logs. So if you want to see the response, what is running in the backend, you can keep verbose to be true. If you don't want to see what is happening in the backend during inference, you can keep verbose to be false. And then you have allow parallel tools to be true. So what this particular thing does is, like suppose if I want to ask a question, what is the capital of France? It will tell me, hey, Paris is the capital of France. So do you think you need a tool for this? No, right? LLM already knows what is the capital of France. So it needs to use its own intelligence. So during this time, you don't have to do the search. It will directly use its intelligence. So this parallel mechanism on when it needs to use its intelligence, when it needs to use the tool, this will be decided by allow parallel tools to be true. And once this is done, you just have to run agent.chat and your user query. So this is how actually you can build an React agent. And how do you build a LATS agent? Instead of importing React agent, just import LATS agent, and you just have to replace this keyword. You just have to replace one keyword, and you're able to build your first agentic workflow. Yeah, and what are the use cases that we can build? I'll just tell you what use case we have built at our startup. The first thing is core technical documentation. We have a GitHub repository by named OpenAGI and also Beyond LLM. Whenever we add a new piece of code, right, we have an agent which will give us a technical documentation. We just copy the documentation and we add that on our Git book. So this is one of the use case. And the second thing is assignment evaluator. Since we keep hiring interns for every 3 months, there are tons of assignment that we get. And we have an agent that we have a multi-agent architecture. The first agent will look at the resume and check if he is valid or not. And the second agent will ensure what assignment they have submitted, if it is correct or wrong, and whether it is up to the standards or not. And this is how we have built the assignment evaluator. And the tools that we are using here is a GitHub tool. Why? Because we need to get the information from a GitHub and then do the analysis part. That analysis part, we have Claude LLM that is doing it. So this is the second use case, which is assignment evaluator. Then you have curriculum content preparation. So at AI Planet, we also have few boot camps that we host. So lately, we hosted a boot camp on RAG and agents. In order to prepare the curriculum for that, we use the complete agent to get the content preparation and also the code snippet from GitHub. So for that also, we used an agent. And last, we have a marketing team. Like suppose if we have any customer, if you want to generate the use cases and what is the mission, and who are the competitors for that company, we have one more marketing agent which we have built. So this approach is what we call as multi-agent architecture. For that, we have our library, which is OpenAGI. It's completely open source, and you have few cookbooks that you can look into. And in order to implement, right, it's pretty similar to Llama Index. The only thing is, instead of running one agent, you're running 3 to 4 agents at a single time. So this is the GitHub repository of OpenAGI. If you are interested in learning more about agents, you can take a look at cookbooks and examples. You will find around 20 examples. All right. So for more resources on retrieval augmented generation, I have a playlist on it. I have different retrievers that you can use. And for every single video, we are using Hugging Face, which is completely open source LLMs, so that you don't have to use OpenAI credits to build and drag application. Cool, yeah, that's it from my talk. And if in case you're interested to get these slides, because there were too much of research papers in it, so you can just take a copy of this particular URL so that you can get the access of the entire slides. Yeah, thank you.
Okay, thank you again, Mr. Tarun Jain, for your insightful presentation. That was an insightful talk. Please give a round of applause to our speaker today, Mr. Tarun Jain. This concludes our session for this class. We hope you found it insightful, and we encourage you to continue exploring Python in your projects. And a big thank you to everyone who participates today. Have a great day, and please wait for another session after this. Thank you so much.
Thank you.
Ayo. Kamu foto nggak tadi?
Thank you for the good insight. I have a question about the how to manage that performance, because I saw there